Up until this point in the class, we haven't created a lot of classes, so we haven't had to think much about organising those classes. As the course progresses, we're going to be using more and more of Java's libraries, and our applications are going to get more complex. This feels like a good time to talk about the package and import statements in more detail. I've talked briefly about import statements when I used the scanner class, and I mentioned packages when I talked about access modifiers. In this video, I want to focus on what a package is, why we'll be using them moving forward, and how to access classes in different packages. As per the Oracle Java documentation, a package is a namespace that organises a set of related types. In general, a package corresponds to a folder or directory on the operating system, but this isn't a requirement. When using an IDE like IntelliJ, we don't have to worry about how packages and classes are stored on the file system. The package structure is hierarchical, meaning you group types in a tree-like fashion. You can use any legal Java identifier for your package names, but common practice has package names in all lowercase. The period separates the hierarchical levels of the package. By now you're familiar with two of Java's packages, java.lang and java.util. On this slide, I'm showing these two packages with some of the classes we've used to date, as shown within these packages. You may remember, when we used the scanner and random classes, we were required to use an import statement. I'm showing you an example of using the scanner class in this code. The import statement has to be declared before any class or type declarations, but after any package statement. In this code, I don't have a package statement, so the import statement must be the first statement in the code. There is no limit to the number of import statements you can have. This code shows two import statements, one for the random class and one for the scanner class. Alternately, we could use a wildcard with the asterisk character in the import statement. In the following code, we're telling Java to import all classes from the java.util package with the use of the asterisks after the java.util package reference. Packages let us reuse common class names across different libraries or applications and provide a way to identify the correct class either with an import statement or a qualifying name. For example, you might have a package for utility classes that can provide common functionality for all of your classes to access. Packages let us organise our classes by functionality or relationships. Packages also let us encapsulate our classes from classes in other packages. You might have a package of tightly coupled classes that should only be accessed by each other, but not by the outside world, as an example. We've seen that Java starts their package names with Java in some of the examples we've looked at. However, it is common practice to use the reverse domain name to start your own package naming conventions. If your company is abccompany.com, for example, your package prefixes would be com.abccompany. For the rest of the course, I'll be using dev.lpa, which is the reverse domain of one of my Learn Programming Academy domains. The package name hierarchy is separated by periods. The package statement needs to be the first statement in the code, with the exception of comments and whitespace. The package statement comes before any import statements. There can be only one package statement because a class or type can only be in a single package. In this code, I created a class called main. A class's fully qualified class name, FQCN, consists of the package name and the class name. So this class's fully qualified name is dev.lpa.package_1.main. It's unlikely this class with its fully qualified name will have a naming conflict with a main class in another package. As another example, the fully qualified class name of the scanner class in this code is java.util.scanner. You can use the fully qualified class name instead of the import statement, as I show you here on this slide. This code does not use the import statement, but instead where the scanner class is referenced, the fully qualified class name is used. You can probably imagine this could get very tedious very quickly if you wrote your code this way. Later in the course, I'll talk about using a combination of the import statement and the fully qualified class name to resolve conflicts. In this slide, I'm showing two classes from our previous challenge in the unnamed or default package. This is where classes are implicitly placed if we don't specify a package statement. For your applications, you should always specify a package statement and avoid using the default or unnamed package. Although that's all we've been using up until now, it has some disadvantages when you work in a true development environment. The main disadvantage is that you can't import types from the default package into other classes outside of the default package. In other words, you can't qualify the name if it's in the default package, and you can't import classes from the default package. Okay, so that's the package and import statement basics. Let's jump into IntelliJ and see how to create some packages there. In IntelliJ, I've created a project called Packages but haven't done anything else. I have the project panel open. You can create the packages first by right-clicking on the SRC folder, selecting New, then Package. And here I'm going to type in dev.lpa, which will be the base package I'll be using from now on in the course. And as you can see, IntelliJ created a folder system with dev.lpa under the SRC folder. If you'd rather see the individual folders, click on Gear, Tree Appearance, and then uncheck Compact Middle Packages. And now I can create a class under the LPA folder by right-clicking it, selecting New Java class, and then entering the name of the class I want, main in this case. As you can see, IntelliJ includes a package statement at the start of this new class now. You can create your package structure this way and add classes under the relevant packages. An alternate way to do this is to simply include the full package structure in your new class name. But you have to be careful where you're creating the new class. I'll create a new class, but this time I'll include the package structure. Let's say our package structure is going to be for our abc.com company, so I'll start by entering the package name, com.abc.first, so another period, and then item. And now you see IntelliJ has both created the package folders and created a class called item at the same time, nested in the right folder. And again, the package statement was added to the source file for us. Those are the different ways to create packages in IntelliJ. I'll quickly add a field and constructor, private string type, public item parentheses with a parameter of type string called type, this .type equals type, and I'll add a toString method just below the constructor. Now I'm going to use this class from my dev.lpa.main class. Going to that class, I'll create a main method with the PSVM shortcut. Now I want to create an item. I'll start by typing item, and what I want you to notice is that IntelliJ is displaying all the classes that it knows about that start with the word item, and at the top is my com.abc.first.item class, which we just finished creating. If I select that first class, IntelliJ adds the import statement for me, and I can continue to create an instance of item. Item first item equals new item, and I'll pass the literal string burger. And I'll print out our newly created instance. And I can run the main method now using this item class from the com.abc.first package. And if I run that, you can see the output item type equals burger. As you might imagine, item as a class name might be used in a lot of applications, so the import statement lets us tell the compiler which item class this is referring to. I'll be going into this approach in a lot more detail in a future video. I've said that you could use a fully qualified name instead of an import statement, so let me just show that to you next. I'm going to retype the first statement using the fully qualified class name. Because I have those auto import settings configured, once I finish typing the new line of code, the import statement will disappear. com.abc.first.item. First item equals new com.abc.first.item with the literal string burger, again as the argument. And the import line got deleted by IntelliJ automatically. Okay, so that's another way to use a class from another package, but you can imagine that if I have to reference that class name more than a couple of times, typing it this way could get ugly really fast. I'll revert that code back to the way I had it, and the import line has reappeared. In the import statement, I'll replace item with an asterisk. And this code still compiles if I use an asterisk. An asterisk is a wildcard which says import all classes from this package. I only have one class in this package, and I'm only using that one class, so the asterisk doesn't do much for me in this example. In truth, with the introduction of the IDE, the use of the asterisk is less common because it's more descriptive to include an import statement for every class individually, but you may still see it used in some code. Okay, that's the introduction to packages and import statements. I'm going to be using these from now on, so there will be plenty of time to go over more of the details as we progress. Modules are another level of organisation that are relatively new to Java, and I'll also be covering these in their own section much later in the course. This video ends the object-oriented introduction sections of this course. The next video starts a new section on another important Java feature, the array. I'll see you in that next video.